Hey everyone, this video is on solving trig equations using identities. So make sure that you have your identity paper handy so that way we can look back at these identities to help us out when we are looking to solve these equations. We want to solve for 3 sine x plus 3 cosine of 2x equals 2. This one right here is a really tricky one because if you notice, we have sine of x and cosine of x right here. And to be honest, if I can avoid solving an equation with both sine and cosine in it, it would make things so much easier for me. So let's look back at the second page of our notes. We see that we have cosine 2x in our problem. And we also have sine in our problem. So I can rewrite cosine of 2x as any of these options right here. But I think I would prefer to use this one because if I use this one, then I will only have sine of x in my equation right here. I would have sine squared, but at least it would just be sine. Since I know that cosine of 2x is equal to 1 minus 2 sine squared x, then I can just rewrite this whole entire equation as 3 sine x plus 3, and then I'm going to replace cosine 2x with 1 minus 2 sine squared x. And then I'm going to say that that's equal to 2. And then I'm going to go through and I'm going to go ahead and do my u substitution. So here I'm going to say let u equal sine x because then I only have to substitute u in for the sines. So here I'm going to say 3u plus 3 times 1 minus 2u squared is equal to 2. So let's go ahead and just do our basic algebra, distribute the 3 through. And I want to get everything all together on one side because this is quadratic. And I'd rather get everything on the right side so I can make this minus 6u squared a positive 6u squared. So here I get 0 equals. When I add the 6u squared on this side, I have a positive 6u squared. When I move the 3u over, I would get minus 3u. And then when I move the 3 over, I would subtract it. So I would get minus 1. And then I can go through and I can try to solve this by factoring. There's no GCF, and it's not a difference of perfect squares. I can't factor by grouping. It's not a trinomial. I don't want to use factor theorem. I don't want to do any of this stuff. I just want to probably see if I can factor as a trinomial. And I'm telling you right now that I wouldn't be able to because there's no way that I could get factors that would work right here. You can also check by doing the discriminant if you want to as well. So because factoring doesn't work, I would try to use the quadratic formula. So here I would say u equals 3 plus or minus the square root of b squared, which is negative 3 squared, minus 4 times 6, which is a, times negative 1, which is c, all over 2 times 6. I'm just using the quadratic formula. So here I would get u equals 3 plus or minus the square root of 33 all over 12. So here what this means is u would either be 3 plus the square root of 33 over 12, or u equals 3 minus the square root of 33 over 12. Okay, so now that I've done that, I've solved for u, I can now go back and replace the u with sine of x. So here I can say that sine of x would be equal to 3 plus the square root of 33 over 12, or sine of x equals 3 minus the square root of 33 over 12. And I want to know, are these numbers even possible? Because remember, again, sine can only be between negative 1 and positive 1. So I'm going to go to my calculator and try to figure out what these numbers are. So my first number right here, 3 plus the square root of 33 all over 12, is approximately 0.7287. So here, I'm not going to use this number, but I am just going to write myself a note that this is 0.7287. This is possible. Sine of x is allowed to be 0.7287 because, again, sine of x has to be anywhere between negative 1 and positive 1. Now let's figure out what this number would be approximately. So instead of plus, I'm just going to delete this, make this a minus. I get negative 0.2287, which is also possible for sine, because again, sine can be anywhere between negative 1 and positive 1. So now that I've done that, Both of these numbers are viable options. However, because this one is positive, sine is positive in quadrants 1 and 2. Because this one is negative, sine is negative, in quadrants 3 and 4. I'm going to bring this back up here because I'm running out of room. So we've gotten to a point where we have, again, I'm just going to copy this down. Sine of x is going to be equal to 3 plus the square root of 33 all over 12. Or sine of x is equal to 3 minus the square root of 33 over 12. And again, I'm just going to write on top right here 0.7287 and negative 0.2287. And then I'm also just going to write myself a note that this is for quadrants 1 and 2. And here we're looking at quadrants 3 and 4. Okay, so we need to find a related acute angle right here. So for this right here, I would say sine of beta is equal to, and I don't want to use the decimal approximation. I want to use this exact answer, so that way the less rounding I do, the more accurate I have as my answer. So that means beta would be the inverse sine of 3 plus root 33 all over 12. I can type that into my calculator. So I would go to function, I would do the inverse sine of, and then I would open up my fraction, and I would write 3 plus the square root of 33 all over 12 right here, and I would get 0.8164, so on and so forth. But if you don't have this functionality in your calculator, you can just do 3 plus the square root of 33 in your calculator, get an answer, take your answer, divide that by 12, get that answer, and then you can just go to the inverse sine of that answer, and you still get that 0.8164 that we got up here. So here we know that beta is going to be 0.8164, okay? Now, for this one's a little bit trickier, so pay really close attention to this, because this whole entire expression ends up being a negative number right here. When I want to find my related acute angle, just like we always do, like for example, don't write this down, but if I have sine of x equals negative 0.4, we would say sine of beta equals positive 0.4. We would just change the sign. Well, I would do the exact same thing here, except this is such an ugly number. So what I would do is I would say sine of beta is the negative 3 minus root 33 over 12, which means that beta is the inverse sine of negative and then 3 minus root 33 all over 12. Close this bracket and then close this bracket. Type that into your calculator and you would end up getting, I would do inverse sine of negative, and then I would open up a new bracket right here, and then I would say 3 minus the square root of 33 all over 12, and I would end up getting 0.2308. So I know beta is 0.2308. But if you remember right here, the answers to this are in quadrants 1 and 2 because sine is positive in quadrants 1 and 2. So that means that my first answer for x would just be 0.8164. My second answer for x would be in quadrant 2 right here with a related acute angle of 0.8164. So my second angle right here would have to be pi minus 0.8164. So my second angle is approximately, and if you noticed, I actually typed in b here for my beta, and then now I'm going to do pi minus the b because I want to get, I don't want to do any rounding until the final answer right here. So I end up getting 2.33. So my second value for x would be 2.33 radians, okay? And then this one, I'll be consistent right here. Let's actually make this value right here 0.82. Now let's go ahead and look at our next answer for beta right here. So our other related acute angle is 0.2308. But it was originally the inverse sine of a negative number, which means we're looking at quadrants 3 and 4. So this related acute angle right here is 0.2308 right here, as well as 0.2308 right here. So that means that my x3 would have to be pi plus 0.2308. And then my second angle would have to be 2 pi minus 0.2308. So then I would just type those into my calculator. But now I'm just going to change this back here into the number that we got before. And so I got 2.308, but now I want to do pi plus my angle right here, plus the b. So we get 3.37. That's my first answer. And then my second answer would be 2 pi minus beta, or 2 pi minus 0.2308, and that would be 6.05. So that means that my answers are 3.37 and 6.05. So now if I were to write my answers, all four of my answers in numerical order, they would be 0.82, 2.33, 3.37, and 6.05 radians. All right, so in number 2, one thing that I want you to notice is that both of the angles in this equation are both 3x. So it will be easier for us to do a u substitution for our angle. So we'll rewrite this as secant squared u minus 2 tan squared u equals 0. And also, I really don't want to have two completely different trig identities here to solve this when there is a subtraction sign between them. So I'm going to take a look at my trig identities. And because I have secant squared and tan squared, it might be easy for me to use this identity right here to help me out. So I know that secant squared theta is equal to tan squared theta plus 1. So if I look at this right here, I can replace this with tan squared theta plus 1. And then just copy the rest down. But sorry, I don't mean theta. Tan squared u plus 1. And then we'll copy down this minus tan squared, 2 tan squared u equals 0. So now I'm just going to collect my like terms. So tan squared u and negative tan squared u would collect together to give me negative tan squared u. I'm going to move the tan squared u over. So now I know that I can square root both sides. Why? Because this is a perfect square on one side and a single number on the other side. Now be very careful about this next part right here, because when I take the square root of 1, I get plus or minus 1, and it's very important that you remember that that is the case. So because we have a positive 1 and a negative 1, we know that our answers are going to be, for you, are going to be in all 4 quadrants. So I'm going to have 4 answers for you within 1 period, okay? So I also know that the tangent, so first of all, let's actually find our related acute angle. So we're going to say the tangent of beta equals 1, which means that beta has to be, and if you remember, in our unit circle, root 2 over 2 works for pi over 4. So beta is equal to pi over 4. But because we're looking at all 4 quadrants, we're going to have 4 answers for you. So we could have pi over 4. That's this answer up here. The second answer would be 3 pi over 4 because it's pi over 4 away from pi. If you want to do the work on the side where you do pi minus pi over 4, go for it. But I'm going straight to these values here. This next one right here is going to be pi plus pi over 4, which is 5 pi over 4. And then this last one right here is 2 pi minus pi over 4, which is 7 pi over 4. But that's what u is. And we want 3x. So here I'm going to say 3x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, because u and 3x are the same thing. And then I can divide everything through by 3. So when I divide this by 3, I get pi over 12. When I divide this by 3, I get pi over 4. because the 3 here and then the divided by 3 here would cancel out, so I'd get pi over 4. When I divide this by 3, I get 5 pi over 12. And then when I divide this by 3, I get 7 pi over 12. Okay? But I need to make sure that my answers are within this domain that we have here. So these are my 4 basic answers within one period, but I want to find out how big my period is. And a period is 2 pi over 3 because it's 2 pi over k and the k value is 3. Well, this right here is a difference of 2 pi. From negative pi to pi is a difference of 2 pi, which means that we are going to be looking at 3 periods within this domain right here. And in each period, if I have 4 answers, and I have 3 periods, and I should have 12 answers. So to find the next set of answers, I'm going to add a period. And a period is 2 pi over 3. But 2 pi over 3 is really 8 pi over 12. So let's go ahead and add that to each one of these values here. Remember, pi is the largest that we can go. So when I add pi over 12 and 2 pi over 3, or pi over 12 and 8 pi over 12, I get 9 pi over 12, which is 3 pi over 4. When I add pi over 4, which is 3 pi over 4, with 8 pi over 12, I would get 11 pi over 12. If I add 5 pi over 12 and 8 pi over 12 together, I would get 13 pi over 12, but that's too large. That is bigger than pi. So far I have 1, 2, 3, 4, 5, remember these are equivalent to each other, 6 answers. So I've gotten half of the answers that I think I should get. So now I'm going to take all of these answers that we had before here, and now I'm going to subtract a period from each one of these. So I'm going to rewrite these all out. So I'm going to subtract 1 period, and my 1 period is going to be 2 pi over 3, or subtract 8 pi over 12. So when I subtract 8 pi over 12 from pi over 12 right here, I get negative 7 pi over 12. Sorry, this is just pi over 4. When I subtract 8 pi over 12 from pi over 4, I get negative 5 pi over 12. Subtract these right here, I get negative 3 pi over 12. And when I subtract these right here, I get negative pi over 12. So far, so good. Here's 4 more answers, and these 4 answers here still fall within my period here. And then I know that I have 2 more answers. So I'm going to subtract 2 pi over 3 from the 2 largest answers here, because the 2 smallest answers will be too much right here. So I end up getting negative 3 pi over 12 minus 8 pi over 12 would be negative 11 pi over 12. And then negative pi over 12 minus 8 pi over 12 is negative 9 pi over 12. So all of this means that my 12 final answers are going to be negative 11 pi over 12, negative 9 pi over 12, negative all of 4 of these answers right here, and then these 4 answers here. I'm just putting these in order from smallest to largest. And then these last 2 answers right here, which are 3 pi over 12 and 11 pi over 12. But just one quick notice, one quick thing that I noticed, I have negative 9 pi over 12, which can be reduced. So we'll probably want to write this as negative 3 pi over 4. And these are my 12 answers. Here I wrote 3 pi over 12, but I meant to write 3 pi over 4. And then over here, with this answer over here, I apologize, negative 3 pi over 12 would reduce to negative pi over 4. And now we're good. All right, and now in our last question right here, I want to bring your attention to the fact that there is no domain right here. So this means that we're looking for the answers for under all real numbers, like all the infinite possible solutions. And we'll talk about how to write it out, because obviously you're not going to want to write out infinite solutions. So for starters, if you notice here, we have 2x and we have x. So our angles don't match, which means that I have to figure out a way to get my angles to match to be able to solve this. I cannot solve an equation if my angles don't match right here. The best way to solve my equation is to get my angles and my trig identities to match, because the cosine of x is not the same thing as the cosine of 2x. So I need to be able to get this in a way where I can actually kind of like manipulate this myself. So what I'm going to do is I'm going to take a look at cosine of 2x. I'm going to go to my formula sheet. And I'm going to look for where it talks about the cosine of 2x. And if you look here, we've got three options. We either have the cosine of 2x equals cosine squared minus sine squared, or it's equal to 2 cosine squared minus 1, or it's equal to 1 minus 2 sine squared. Now, we have to be strategic about which of these to choose, because all of these are equivalent to cosine of 2x. So if you look right here in this problem, we have a cosine of x right here, which means that whichever one that I choose here should also have a cosine of x in it. So here are my two options right here. I would not use this one right here. But also, this one has a sine squared x, so that makes things difficult for me. So in this particular problem, it makes the most sense for me to use 2 cosine squared x. So here, I'm going to copy this down right here, copy down the 2. And then I'm going to replace cosine of 2x right here with 2 cosine squared x minus 1. Okay? And then I'm going to copy the rest of this equation down. Then just go ahead and distribute that 2 through. If it helps, do a substitution. I'm going to use v this time for cosine of x. So this looks like 4v squared minus 2 plus 10v equals 4. Notice this substitution is not for an angle, but for the full ratio. So here I get 4v squared plus 10v, and then I'm going to subtract the 4 over. I get minus 6 equals 0. Don't forget to factor out that common factor. So then when I factor this out, I get 2 times 2v, and then I'll have a v. And then I'll use a 3 here and a 1 here. This would be a positive, this would be a negative because I get negative v, and 6v, which altogether give me 5v. So this means that v equals either 1/2 or v equals negative 3. But we know that v equals cosine of x right here. So I can say either cosine of x equals 1/2 or cosine of x equals negative 3. Remember, cosine can never be bigger than 1 or smaller than negative 1. So this isn't even possible. I'm not even going to deal with that right here. And for this right here, I'm going to find my related acute angle. So cosine of beta is 1/2. And we know that cosine is 1/2. The x is 1/2 when we are looking at an angle of pi over 3. So here we know beta is pi over 3. Well, if we know beta is pi over 3, and we also know that cosine is positive in quadrants 1 and 4, that means that x would either equal pi over 3 or x would equal 2 pi minus pi over 3, which is 5 pi over 3. But that's the answer in one cycle. Now, another answer that we could get is a whole cycle later. So I could add another 2 pi to get another answer. But then another answer would be another whole cycle later. So I could add another 2 pi. And I could just keep adding 2 pi over and over and over again. And all of these would be possible values for x. So x could either equal pi over 3 plus 2 pi n. And what this means is that you can just repeatedly add or subtract 2 pi. Because if I do 2 pi times n, if n is just a whole number or an integer, then I'm just adding 2 pi n times. So if n is 5, I'm adding 2 pi 5 times. That's 5 revolutions. If n is -4, I'm subtracting 2 pi 4 times. That's 4 revolutions backwards. So we also have to say n is an element of the integers. But the same thing is true for 5 pi over 3. So then we can say right here that our answer is pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n, where n is an element of the integers. And that this letter right here is a z or a z. Okay? All right, and that's how you show your infinite solutions, because if n can be any integer, you can repeatedly add or subtract to n. And that's it for this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.